Welcome back to Math 103. This is video number 5 on apportionment. Last time we were discussing lower and upper quotas and the quota rule. So this is not hard to do. The lower quota of Massachusetts is the standard quota simply rounded down to the nearest integer, so that's 11 seats. The upper quota is 12 seats. Okay, so the standard quota rounded up. Very well, so this is not hard to do. For Connecticut, the lower quota is 6, the upper quota is 7. For Maine, the lower quota is 2, the upper quota is 3. For New Hampshire, the lower quota is 2, and the upper quota is 3. For Rhode Island, the lower quota is 1, and the upper quota is 2. For Vermont, the lower quota is 1, and the upper quota is 2. All right, so what does the quota rule assert about the number of seats New Hampshire may ultimately receive? According to the quota rule, New Hampshire should receive 2 or 3. So it should not receive fewer than 2 seats, it should not receive more than 3. If it receives fewer than 2, then it will be outraged, it will be really overtly shortchanged. And if it receives more than 3, well, New Hampshire will be happy, but someone else will complain. All right, so the quota rule asserts that 2 or 3 is the number of seats New Hampshire should receive. Whether New Hampshire actually receives one or the other of these remains to be seen, and that will depend on the actual apportionment method. Okay. Now, what would happen if we just gave each seat its lower quota? Well, if you add up all the lower quotas, that would mean that we would give out only 23 seats, and that is bad news. Only apportioning 23 of the seats is not an acceptable answer to this apportionment problem. The fact that there are 25 seats to give out is part of the original information that's given. Right? So the only acceptable answer, the only acceptable answers are answers that add up to 25 seats being apportioned. Similarly, if you add up the upper quotas, if you sum these, you will get 29. It's not surprising that the difference between the sum of the lower quotas and the sum of the upper quotas is 6, because there are 6 states, and none of them had a whole number as its standard quota, right? So, the difference figures to be 6, and if we attempted to give out 29 items when we only have 25 to give out, that too, of course, is not acceptable. This is perhaps even clearer why it's unacceptable. If you gave out only 23 seats, you might be tempted to say, well, we'll just stop there and have 2 leftovers, although that's not actually allowed. It's even clearer why you can't give out 29 seats if there are only 25 in the first place. This brings us to Hamilton's method of apportionment, a method that was actually implemented in American history. In fact, it was passed by Congress to be used as the first apportionment method, but George Washington vetoed it, and that was the first presidential veto in American history. He vetoed it in favor of Jefferson's method, Jefferson, his fellow Virginian, and we'll discuss Jefferson's method later on. So how does Hamilton's method work? First, give each state its lower quota of seats. So make sure, first of all, no one gets shortchanged beyond the lower quota. Some states might get just their lower quota and feel a little bit shortchanged, but no one will be shortchanged any more severely than that. Now, this will typically, virtually always, leave 1 or more surplus seats, which still need to be apportioned. As in the previous example, if we just gave out the lower quota to each state, we would have only 23 seats accounted for and 2 left over. So the number of surplus seats equals the total number of seats, for example 25, minus the sum of the lower quotas, for example 23. Okay, so 25 minus 23 gave us 2 leftover seats that still had to be given out to somebody. Now, to decide how to apportion those surplus seats, to decide who gets those 2 leftover seats, look at the decimal part of each standard quota. Okay, in other words, this is the part to the right of the decimal point, the part that's getting thrown away when you round down. The state with the largest decimal part is apportioned the first surplus seat. Okay, it is the most deserving of being rounded up instead of being rounded down. If you still have more surplus seats after that, great. The state with the second largest decimal part is apportioned to the second surplus seat, if there still is one. Okay. You continue until all the surplus seats have been accounted for, until they've all been given away. Let's apply Hamilton's method of apportionment to the 25 seats in Red Sox territory, as in our example. All right, so we've already found all the hard stuff. All right, we did all the work to find the standard quotas. We have already found all of the lower quotas. So now we just have to go through and take note of which decimal part belongs to which state. Okay, so each state has a certain portion of its standard quota that was thrown away when we rounded down. And it makes sense, actually, that if you added up those decimal parts, you would get, apart from a little bit of round-off error maybe, you would get the number of surplus seats. Okay, so there are 2 surplus seats that have to be given out here. Now, to follow Hamilton's logic, we're going to first write down everyone's lower quota, and then notice that certain states deserve 1 extra seat. Who deserves 1 extra seat? Well, Rhode Island has the highest decimal part. It is most deserving of being rounded up instead of down, so it gets a surplus seat. And then, who is the second most deserving after Rhode Island? Well, the second highest decimal part belongs to Maine. Okay, so it's Rhode Island and Maine that have the 2 highest decimal parts. So Rhode Island and Maine are the ones that each get 1 extra seat. Great, so we've given out 2 surplus seats, and that's all the surplus seats we had, and therefore we're done. So Massachusetts gets 11 seats, Connecticut gets 6, Maine gets 3, New Hampshire gets 2, Rhode Island gets 2, and Vermont gets 1. When you add these up, sure enough, you have given out 25 seats. So this is the Hamilton apportionment. When you are asked to find the Hamilton apportionment, that means produce these numbers. Produce the number of seats that each state ultimately, at the end of the day, receives. And you should always check that that really does add up to the proper number of seats in total. Before going on to the next video, consider a variation of our example in which there are only 21 seats to apportion instead of 25, and find the Hamilton apportionment. The populations are still exactly as they were. Okay, this is expressed in millions. This is the same number as before. It's just written in shorthand as 6.3 million out of 13.9 million. Okay. You are going to need to recompute standard quotas. All right, because Massachusetts now has a certain share of 21 seats instead of having a certain share of 25 seats. So this number here is going to be different. Each of these standard quota numbers will be a little bit different. So you do have to recompute those, but if you think about it, there is a piece of earlier work we did that you can use to make this computation a little bit easier. Once you have the standard quotas, you need to find lower quotas, decimal parts, and finally the Hamilton apportionment.